Okay, we've got a little sketch here that depicts the situation. A circular swimming pool with a diameter of 10 meters, meaning the radius is 5. The height of the pool is 3 meters, and we've got the pool filled to a depth of 1.5 feet of meters, which is represented by this blue section. And we want to lift all of this water over the top of the pool and how much work is required. So work is the integral of force times distance that typical slices move. So this red section here is a typical slice. And the volume of that slice, since it's a circular disc, is pi r squared times the height of that little wafer or slice. And that is represented by delta y, or the change in y, or dy when we get to the integral. So there is the volume of a typical slice, always 25 pi times whatever the thickness is. The mass of the slice, since each cubic meter weighs 1,000 kilograms per meters cubed, we have to multiply that by 1,000. So 25 times 1,000 gives us 25,000. Gravity is pushing down on that slice, which we have to overcome. So the force of this on the slice is acceleration due to gravity, 9.8 meters per second squared, times the mass gives us that force on the slice. And the distance that slice has to move in this coordinate system, this particular slice is y meters above ground level. So the distance that slice has to move is 3 minus this y. It doesn't have to move the entire 3 meters. So there's your and the slices occur between 0 and 1.5 meters. So we have infinitely many of these slices that we're going to integrate. 0 to 1.5 or 3 halves of 245,000 pi times the distance that the slice has to move. Okay, this is a constant. We can move that out front. The antiderivative of 3 minus y is 3y minus 1/2 y squared, evaluated from 0 to 3 halves. Gives us 27/8. Of course, there's a minus 0 here. We put 0 in for y. And that translates to 826,875 pi joules. You could get a decimal approximation by multiplying by 3.14 for pi, 22/7, whatever you want to use for pi. The only thing that changes for part B is the distance that a typical slice has to move. Instead of just going over the top, we're all the way up here to 5, 6, 7. I'm sorry, 3, 4, 5, 6. So we got to move the slice all the way up to here. And so the distance is 6 minus y. So the only thing that changes for part B is that 3 becomes a 6 for part B. And that means that's a 6. And 6 times 3 halves is 9. So this is a 9. So obviously the work is going to be greater. There you go. Hope that helped. If you have any questions, post a comment.